Hi everyone, I hope you all are doing well. Welcome to Online Study for You, a complete placement solution. Today we'll be solving previous year coding problems that were asked in Accenture exams on 1st September 2023. But before starting the video, I would like to request you to hit the subscribe button and the notification bell so that you don't miss any updates from our side. Now let's move to the first problem that we have. So, in the first problem, it's given a number n. You have to write a function that returns count of numbers from 1 to n that don't contain digit 3 in their decimal representation. So, what do you have in your input? In your input, you have an integer n. So, you have to write a function that returns count of numbers from 1 to n. So, you have to count numbers from 1 to n that don't contain 3 in their decimal representation. Suppose you have an example 258. So 258, you have digits 2, 5 and 8. And in these 3, it doesn't contain any 3. So this can be a valid number that you can count. Another example, we can say you have 351. Here in this number, you can see here it is a 3. So this number will not be counted in your answer. Another example that I can take is 999. 999 also doesn't contain 3 in its decimal representation. Decimal representation means this number that we have 999. So this can also be counted in your answer, but 351 was not counted. Suppose now what they have written, just see at example 1 where you have an n equal to 10. So you have to count numbers from 1 to n. 1 to n means from 1 to 10. So what are the numbers? We have 1, 2, 3, 4, 5, 6, 7, 8, then we have 9, and then we have 10. In these 10 numbers, how many numbers are there that don't contain digit 3? So, as you can see, this will be counted 2, then we have 4, will not count 3 because it contains digit 3. So, what was the count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, how many numbers are there? There are 9 numbers. If we'll talk about another example that we have, so you have n equal to 45. So here, what you'll write, you have to count from 1 to 45. When you'll see from 1 to 45, the first number that contains 3 is 3, then you have 13, then you have 23, and so on. So, numbers that don't contain 3, so the total count of those number is 31. Another example, if I'll take, is 2. Just look at this. So when your n is 2, so you have to count numbers from 1 to 2. So what are numbers 1 and 2? Does these numbers contain 3 in their decimal representation? No. So the output will be 2. Correct? Suppose when you have example as 3, then what will be the numbers from 1 to n? 1, 2, 3. How many numbers are there that don't contain digit 3 in its decimal representation? So, n was 3. N is 3 and the output we'll get will be 2 because we'll not count this. Do not count this. Got it? Okay. So till now from observation we have seen that if we have observed that just give me a second. Correct. So we have seen if your n is less than 3, assuming there are only positive integers, there are no negative integers. So in that case, your count of numbers will be equal to n because you are not including 3. 3 will be the first number that will have digit 3 in its decimal representation. But suppose if your n is greater than 3 and it lies between 3 and 10, 3 and 9, 10 is excluded over here. So in that case, you will encounter one number that will contain digit 3. That will be the number 3. So what you will do? You will just do n minus 1. You will just deduct 1 from the n. Why? Because there is only one number that contains digit 3. And which is that number? That number is 3 only. Okay, got it? Now, how we will come to this approach? So, till now, I have discussed two base cases with you. When your n is less than 3 and when your n is greater than 3 and it is less than 9, means n lies between 3 and 9. So, in that case, you will return n minus 1. Clear? Now, suppose if your n lies between, if your n is larger than 9, okay, what you'll do in this case? So suppose you have a number 45. So what is the first step? First step will be calculate MSD. What is MSD? So MSD is the most significant digit. Suppose you have a number 45. So the most significant digit will be the first digit from left side. So in the number 45, which is the first digit from left side? This is the left side. First digit is 4. So MSD will be 4. First step was to calculate MSD. Okay, now you calculated MSD. Now, what is the next step? You have to check if your MSD is equal to 3 or it's not equal to 3. Okay, that's another thing. So you will compare MSD with 3. There can be two cases if it's equal and not equal. Okay, so if it is equal, then what you will do? But before checking it, you have to calculate the power of 10. X. Calculate power of 10. What do I mean by this? Suppose when you have a number 45. So for 45, the power of 10 will be 10 because there are two digit ones and tens. When you have a number 258, the power of digit will be 100 because there are three digits ones, tens, hundreds. And every time when you will divide it by power, you will get the digit single digit. What do I mean by this? Just check out the fourth step over here. When you have to count the numbers that starts with MSD. The first step will be calculate the numbers that starts with MSD. When your MSD is not equal to 3, what is the first step? First step is you have to count the numbers that start with MSD, which it is written count 4. So in the number 45, the MSD is 4. So you will calculate count 4. When you will call the function count 4, so 4 lies between which 4 lies between 3 and 9. 4 is greater than 3, and so how many numbers will be there that don't contain digit 3? So here answer will be 3, that is n minus 1. N was 4, 4 minus 1, which will be 3. So you have done first step, you have counted MSD. Now what is the next step? The next step is count PO minus 1, that is power of 10 minus 1. So power of 10 was, the power of the number was 10. 10 minus 1, which is count 9. When this count is a function name that I am assuming. So count 9. So 9 is also greater than 3. It lies between 3 and 9. So what will be the answer? Answer will be n minus 1. N is 9. So it will become 8. Okay. Now you have done two steps. You have counted MST, the numbers that start with MST, and also you have count the numbers that are formed by the remaining digits. Formed by the remaining digits means the numbers that can be formed by the remaining digits excluding the MST. You have excluded MST and now you are counting the numbers that can be formed by the remaining digits that we have. Now, what you will do? Another thing that you will count will be N by PO. What does this means? That means N mod PO. When you will divide number N by power of 10, so number was 45, when you will do 45 by mod 10, the remainder will be 5. Got it? And for 5 also, we will apply n minus 1 and your answer will be 4. Got it? So, what we did in 3 steps, we have counted number that start with MSD, we have counted the numbers that can be formed by remaining digits using count PO minus 1, and then we have counted the numbers that can be formed after MSD, that is after 4. Okay, which will be count of 5. Correct? And at last, what you can do, you can use the formula. Which formula? You can use the numbers that you have counted with that starts with MST. Also, the numbers, count of numbers that can be formed by the remaining digits plus the numbers that starts with MSD plus the numbers that are formed after MST, that starts with after MST. So that is N mod PO. So count of MST was 3 into count of PO minus 1 was 8. We have calculated above. Count of MST is again 3, and count of N mod PO, that is the numbers that start after MST, that is 4. So when you will do the sum, it will become 24 plus 3 plus 4. Correct? What you will get? 24 plus 4 is 8 and plus 3, which we get is 31, which is the correct answer that we looked in the input. Uh, just checked out this input for 45, the output we got is 31. Correct? So, this was when your MSD is not equal to 3. Just check out the case when your MSD is equal to 3. In that case, suppose when your MSD is equal to 3, I'll write over here when MSD is equal to 3. Suppose you have a number 35. For 35, the first number that comes from left side is 3. So MSD is 3. For that, you will use the formula count MSD into PO minus 1. That is MSD count of MSD into power of 10 minus 1, which will be count of MSD was 3. Power of 10 here is PO will be 10, 30 minus 1, which will be count of 29. And for 29, again, it will check for recursive leap. Correct? Now, now it's count 29. Again, MSD will be calculated. Now MSD is 2. Now this formula will be applicable because now your MSD is not equal to 3. Then you will come to this step. I have summarized the steps. First of all, you have to check two test base cases. If your n is less than 3, then you will return n. If your n is greater than or equal to 3 or less than 10, the output will be n minus 1. You can simply return n minus 1. Then, for the numbers that are larger than 9, you have to calculate MST. Okay, and after calculating MST, you have to compare it with 3. If it's not equal to 3, you have to do 3 steps. You have to count numbers that starts with MST. You have to call it recursively. Then you have to call a function for PO minus 1. That is the numbers that can be formed by the remaining digits excluding the MST. And third, you have to count numbers that can be formed by after MST. That will be by count n mod PO. When you will divide n by your power of 10 of a number, then what you will get? You will get the numbers that will be formed after the MSD. But if your MSD is equal to 3, you need to count it in a different way. Then you will call the function count, that is function MSD into power of 10 of a number minus 1. So these are the steps that we have to do. I have also summarized it over here. You can just look into it. These are all the steps that I have performed over here for you. Now let's move to the coding part. I'll be coding the problem in C++, but I'll also show you the code in Java. First of all, I'll write the main function int main. Then I'll write int n. Then I'll take the input, and after that I'll I'll print the value that we'll get from the function. So let's name the function contain digit 3, and here we'll pass n. Correct? Now, as we are returning an integer value, I'll write int contain digit 3 and int n. Now, what is the first step? You will check if your n is less than 3, assuming all are positive numbers, there are no negative numbers. What you will return? You'll return n. What is the else if condition? When your n is greater than equal to 3 and your n is less than 10. Then you'll return n minus 1. After that, you have to calculate the power of 10 and MSD. So first you will calculate the power of 10. Suppose I have initialized a variable to calculate power of 10, and you'll write if your n, when you'll divide n by PO, it should be greater than 9. and every time you'll do PO equal to PO into 10. Correct? And now you will calculate MST. So how you will calculate MST? Int MST is equal to N mod PO. Now you have to compare MST with 3. If it's equal, then you have to use different formula. Suppose if your MST is not equal to 3, then what you have to return? You have to return contain digit 3 with MST multiplied by contain digit 3 PO minus 1 plus contain digit 3 MST and plus contain digit 3, which will be N mod PO. Correct? But if it's equal to 3, then what you'll return? Return count digit 3 MST into PO minus 1. Correct? Suppose here if I'll put 45, let's check where are we doing the. So here it will be N divided by PO, not mod PO, to get the most significant digit. So now it's giving the correct output 31. If I'll run it for suppose 7. For 7, the output should be 6 because it lies between 3 and 9. Yes, it's correct. Now, if I'll put it for 2, the output should be n only, that is 2. So we are getting the correct output. This was the code in C++. Now let's move to the code in Java. So here we have a code in Java. So same, if you have n less than 3, then you are returning n, and if your n lies between 3 and 9, then you are returning n minus 1. Similar code but in Java. The difference is only defining the main functions and the using class. Here also if I'll run, you are getting 31 in your output. So this was all about this problem. Before moving to the next problem, I would like to request you all to go through the online study for you and go through this Accenture crash course with 10 mock test series. So here you have course. When you'll click on content, here you can see you have reasoning videos, verbal ability, coding questions, pseudocode, MS application, and Accenture test series. When you'll click on coding questions, here you can see the questions that were previously asked in Accenture exams. Each video contains multiple problems that will help you in cracking the coding test of this exam. When you'll go back, here also you can see we have covered networking, MS Office, and here we have PDFs also, so that you can go through these PDFs a night before your exam. So don't wait, just go and purchase this course. Now let's move to another problem that we have. So you have an array that contains an n elements. So what you have in an input, you have array of size n. Each element is either 0 or 5. You have only two kinds of elements in your array, that can be 0 and 5. Find the largest number divisible by 90 that can be made using any number of elements of this array and arranging them in any way. So you have to find out the largest number that is divisible by 90. Correct? So, suppose when you say any number should be divisible by 90, so what do you mean? 90 will be 9 into 10. then it should be divisible by both the numbers 9 also and 10 also. That means it should be divisible by 9 and 10 both. Correct? Let's look into the example first. When you look in the input, you have 5, 5, 5. Let's count number of fives once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 fives and 1 0. 1 zeros. Correct? In the output, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. In the output, you have 9 fives and 1 0. Why you have taken only 9 fives? Because the number should be divisible by 90 as mentioned in the problem. So, as I told you, it should be divisible by both numbers, 9 also and 10 also. So let's learn about first the divisibility of both the numbers. If I say if a number is divisible by 10, then what do I mean by this? The number should end with 0. That means number should end with 0. Suppose if I take example as 190. 190 is absolutely divisible by 10. When I say 50, when I say 90, these all numbers are directly divisible by 10 because they contain numbers 0 at their end. They are ending with 0. But for 9, sum of digits should be divisible by 9. Should be divisible by 9. Suppose if I'll talk about number 45. So when you will do the sum 4 plus 5, it will give 9. And number 9 is divisible by 9 only. Then I'll talk about another number, suppose 63. So 63 is also divisible by 9 because 6 plus 3 is 9. Correct? 6 plus 3. When I'll talk about another number, suppose I'll talk about 180. So 180 is 1 plus 8 plus 0. It is also divisible by 9 because we are getting 9. Correct? So I told you if the number should be divisible by 90, then it should be divisible by 9 also, and it should be divisible by 10 also. So what do we conclude it? So we have to check the divisibility of both while checking for 90. Okay. Now let's talk about the question that we have. Suppose in an array we have elements like 5, 5, 5, and then we have 0, 0, 0. Correct? This is the number. Are when you will can you form any number from this that can be divisible by 90? I don't think so. You can form because you only have three fives. Okay. And you have three zeros. You cannot form any number. But one number that you can form is 000. This number you can form. So 000 will be the largest number. You are not counting any 5 because when you add any 5 to this number, the number will not be divisible by 90. Another thing is, just look into the first example. We were having 10 fives. Okay. But in the output, we are having 9 fives. Because when you will add 9 times, when you will add 5 9 times, what the number you will get? You will get the number as 45. Okay, so 9 9 9 9 9, 5 times 9, 6 7 8 9. When you will add all these nines, sorry, all these five, suppose, just give me a second. Suppose you have 5 9 times, 4 5 6 7 8 9. Okay, when you will add all these 5, what is the output you will get? You will get 45. Okay, so 45 is directly divisible by 9, correct? But you have to check for a number that will be divisible by 90. Okay, any number of zeros you can add at last, and you can add all those numbers, and you can add any number of zeros at last, so that when you will check the divisibility, it is divisible by 9 also. That is, the sum of the numbers you are getting is 45, and these are ending with zeros also. Okay, so this number is divisible by 90. Okay, number is divisible by 90, is divisible by 90. Now suppose you have in an array, you have 5 5 5. Suppose only 9 times 5 you have. Okay, for 9 times 5, but 9 fives, but you have 0 zeros. You don't have any zeros. So for that, you cannot form a number that will be divisible by 90. So in that case, you will return -1, because the count of number of zeros are 0. Correct? Now, if there are fives, then if there are no fives, that means in an array you have only 0 0 0, any number of times 0. So the largest number that you can form is 0. So in that case, you will return 0 only. Correct? But if both the conditions are not successful, then what you have to do? Then pair the fives into groups of 9. What does this means? This means that I told you earlier that you were having 9 fives. Okay. So when you will group all these fives, there are 9. So you will definitely get a number that will be divisible by 9 when you will make a group of fives in group of 9, when you will group the numbers in 9. So when you will group the numbers, pair the numbers of fives into groups of 9, then you can simply print all the numbers of fives that you have, and at last you can just embed the zeros. What does this mean? This mean, suppose I have 10 fives, 4 5 6 7 8 9 10, and you have 3 zeros. Okay, so first you will count fives. So fives are 10. You will count zeros. when you will count zeros that are 3. Okay, but you cannot form a number with 10 fives that will be divisible by 9. So in that case, what you will do, you will calculate C5. C5 is the count. When you will divide 10 by 9 and you will do into 9 and do the floor of it, then you will get the number as 9. So what you will do, you will just print 5 till C5. 5, 6, 7, 8, 9. Because your C5 was 9. So you run a for loop and print the number of fives till C5 and embed the number of zeros as many as you have in your array. So here I was having 3 zeros, so I have added 3 zeros at last. So this is the largest number that we get by grouping the 5 into the groups of 9. By pairing fives into the groups of 9, we have formed the number and adding the as many number of zeros that we were having in your array. These are the algorithm steps that I have written for you. All these steps I have discussed, I can summarize once again. You have to permutate the number of zeros and fives by calculating the count of zeros and fives by using for loop and while loop. If the number should be divisible by 90, then it should be divisible by both, that is 9 and 10. For a number to be divisible by 10, it should end with 0. And for a number to be divisible by 9, the sum of digits should be divisible by 9. If the count of zeros is 0, that means you don't have any 0 in your array. You cannot form a number because in that case the number will not be divisible by 10. It will not satisfy the condition of divisibility of 10. What you will return? You will return -1. If there are no fives, means you only have zeros. So the largest number that you can form will be 0 only. If both the above conditions are false, means if the count of zeros is also greater than 0 and the count of 5 is also greater than 0, then you can group the number of fives into the groups of 9. Okay, by calculating the floor, that is the count of fives by 9 and into 9. So after that you can print your number of fives till C5, and at last you can embed the number of zeros that you were having. Okay, correct. So I will code this problem. I'll write the main function first of all, and after writing the main function I'll write int n equal to 10 and int array. You have 3, 4, 5, 6, 7, 8, 9, and then you have 0. Correct. Suppose your n was 11. Okay, correct. Now I'm calling function largest number divisible, where I have n array in the passing. I'm passing n and array. Now I'll not return in this function because I'll print directly in the function largest number divisible, and I'll write int n and int array. Correct. What is the first step? You'll count the number of zeros and five. So count 0 equal to 0. I'll initialize two variable. Count 5 is also 0. So I'll traverse the for loop. Int I equal to 0, it will go till n, and I will check if my array of I is 0, then I'll increment count 0 plus plus, and else if it is a 5, then I'll do count 5 plus plus. Because there are only two numbers, so I'm not adding another else if condition, I'm just doing else. Correct. After this I'll check if my count 5 is 0, means there are no fives. Then first I'll check if there are no zeros. Count zeros are 0. Then in that case, you will directly print -1 because you cannot form a number. Correct? But if your fives are 0, so the largest number that you can form was 0 only. So you can print 0. Correct? But after this, when your count 0 is also not 0 and the count of 5 is also not 0, then what you have to do? You have to group the number of fives into the group of 9. So what I'll do? I'll calculate the floor by dividing count of 5 by 9 and also multiplying it by 9. And now what I'll do? I'll start traversing. I'll do int I equal to 1, I less than equal to C5, count 5, and I'll do I plus plus and I'll print the number 5. Correct? And after the embedding all the fives into the group of 9, if I left with zeros, I'll embed all the zeros at last. So I'll do in j equal to 1, j less than equal to count of 0 and j plus plus, and I'll be embedding zeros at last. Correct? Yes. So if I'll run this code, so the number that we are getting is, let's count number of fives: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have two zeros. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this was 10 only. Okay. So when I'll run it, so I'll get 9 times 5 and 1 times 0. Correct. Suppose if I'll change my array and n, suppose my n is 5 and my n does not contain any 0. Correct? There are only 5. So what the output you will get? You'll get -1. It will print here only. Right? And if my in array, I'll not have any fives. I'll have 0, 0, 0, 0, and 0. In that case, what I'll return? I'll return 0 only. Correct. So this was the code of C++. Moving towards the Java code that we have here, we are counting count of 0 and count of 5. Then we are calculating floor using math.flow, right? And then we are checking if your count of 0 is 0, then I am printing -1. If my count of 5 is 0, then I'm printing 0. And then I'm printing the number of fives in the group of 9, and then I'm embedding all the zeros, the count of zeros at last. Here I'm printing using system.out.print that we use in Java, and the function name was print largest divisible that we called over here. If I'll run over here, then I'm getting the correct output. So this was all about all the problems that we have discussed till now. If you have any doubts, do reach out to us. Till that, take care and bye bye. Prepare well for your exams. All the best.